Okay, so next I'm going to go through this problem, which is really just rehashing of the previous example. You know, I had type A integral right here where we had an odd power of cosine. Now we've got an odd power of sine, and we do pretty much the exact same thing. We just use one of the, in this case it was, in this case it'll be the sines that have an odd power. So we're going to scoot one sine over to use as the du, just like down here we scooted one cosine over to use as the du. Okay, I'm not going to go through the rest of the details there that I've got written out. You should think about them and verify them for yourself. I'm going to go through and just do this problem using that idea that if there's an odd power of one of these things, then that can be used as a du. So I look at this problem and I see an odd power of sine. So that means I immediately want to start thinking, okay, let's move one of the sines over to use as my du. Okay, so if I want to use a du, which is going to be a sine of x dx, right? Then I'm going to need to start with a cosine for my u. But then this doesn't quite work out because we need a negative sign, so we will need to fiddle with some negative signs in this one. Okay? That's not bad at all. In fact, the easiest way to fiddle with it is to just, let's go down one line here, move the negative sign over to the inside. Now the sine x dx will be replaced by minus du. Okay? So if I have u equal to cosine x, that means this changes over into u's just fine. This changes over into a du or minus du just fine. That leaves us with the sine of x's. In order to change that into a du, I'm going to have to use our Pythagorean theorem again. Okay? Well, the Pythagorean theorem, recall, says that sine squared x plus cosine squared x is equal to 1. So sine squared x on its own is equal to 1 minus cosine squared x. And here we have, I'll just copy down the rest for now. That means with my u's and du, I see 1 minus u squared times a minus du. And I'll just wrap up that minus sign in terms of here. So I'll take that minus sign and distribute it through this guy. So it looks like this. This is probably the cleanest way to write it. You don't have to do it this way. Anyway, let's distribute that out. And compute any derivative. This will be u to the 5th over 5 minus u cubed over 3 plus a c, and back into terms of x's. I ran out of space on my page here, otherwise I'd be writing downward. 1/5 sine, cosine the 5th minus 1/3 cosine the 3rd power plus a c. Okay, and that's our antiderivative there of sine cubed cosine squared. Really compare this with how we did this problem right here. All right, don't think about memorizing individual rules, kind of like the book tells you to. I would say that's doing yourself a disservice. Well, I don't know. Some of you probably have a lot better memories than I do. So in that case, maybe it is easier for you to memorize these things. But I think really the thing you'll take away with you from this after you leave this section, I mean, how many times are you going to be integrating these things? Well, a lot if you go into certain areas of engineering. But I mean, the real thing you'll take away with you is how to use that u substitution properly. So compare those two examples that we just did. Think about how they're similar and different. Sines and the cosines, odd power. How can we use that to our advantage? Okay. that odd power sine or an odd power cosine.